Number 4, a particle is moving along a horizontal line according to the velocity equation, and that's in meters per second. Part A, if the particle's position at t equals 1 is 6 meters to right of the origin, find a position equation for this particle. So we remember that velocity is the derivative of position, and we list position as our s function. So what we need to think of is an antiderivative for 6t squared minus 30t plus 24. And so we're thinking, what gives this as its derivative? Alright, so what gives 6t squared as its derivative? So that would be something t cubed. And we have to think 3 times what would give us 6. And that is 2. Minus 30t. What gives 30t as its derivative? Well, something t squared. And we have to think 2 times what gives us the 30. 15. And what gives us 24 as its derivative? That would be 24t. Now the thing that's left over is a constant. Because remember, when we take the derivative of a constant, it gets wiped out. So our formula for the position function is given. Now it does tell us some information that helps us figure out what that constant is. It tells us that when t is 1, the position is 6 meters to the right of the origin. So that means positive 6. So 6 s of 1, let's say 1 not t, s of 1 equals 6, which means we plug in 1 for t, we get 2 minus 15 plus 24 plus whatever that constant is. And so here we can just do a little solving to figure out what that constant must be. 2 minus 15 gives us negative 13. Negative 13 plus 24 gives us 11, plus some constant. So our constant is negative 5. Therefore, our position function, we're going to cross off that c, and we're going to put in negative 5.